July 10, 1942. Akutan Island, Aleutian Islands chain. Marine Warrant Officer William Theus trudged through knee-deep marsh grass, leading a patrol across the windswept tundra. Japanese forces had bombed Dutch harbor 6 weeks earlier, and intelligence suggested enemy presence throughout the Aleutians. What Theus discovered that afternoon would fundamentally alter American fighter tactics in the Pacific and expose the fatal compromise at the heart of Japanese aircraft design. The wreckage lay inverted in a bogged tail section jutting skyward, the red circle insignia still visible on gray-green paint. A Mitsubishi, a 6M Type 0 fighter, nearly intact. What none of them knew was that this crashed aircraft would become the most important piece of captured enemy equipment in the Pacific War, revealing secrets that would cost Japan its aerial supremacy. The Zero had dominated Pacific skies since December 1941. From Pearl Harbor to the Philippines, from Wake Island to Java, Japanese pilots flying Zeros had achieved kill ratios exceeding 10-to-1 against American aircraft. The Grumman F6F Wildcat, America's primary carrier fighter, seemed hopelessly outmatched. Zero pilots could outturn, outclimb, and outrange any Allied fighter in the theater. American pilots returned with reports that seemed impossible. Enemy fighters that could turn inside a Wildcat's tightest circle. Aircraft that could climb away from any pursuit. Opponents who could fight for hours over distances that left American planes swimming back to carriers on fumes. Fighter Command dismissed early reports as exaggeration or pilot error. The laws of aerodynamics suggested such performance was impossible in a carrier-based fighter. Yet the kill ratios confirmed Japanese superiority. Something fundamental had shifted in fighter design, and America was losing pilots while trying to understand what. The Akutan Zero had crashed on June 4, 1942, the same day as the Battle of Midway. Petty Officer First Class Tadayoshi Koga had participated in the Dutch harbor attack, strafing installations and engaging American aircraft. During the return flight, ground fire struck his Zero, severing the oil return line. Oil pressure dropped steadily as Koga flew toward the Japanese carrier, Ryujo. Standard procedure called for ditching near the carrier, where destroyers could rescue pilots. But Koga was a highly skilled aviator with over 1,200 flight hours. He believed he could dead-stick land on Akutan Island, a designated emergency landing site 40 miles from Dutch harbor. The island appeared on his chart with a notation indicating flat terrain suitable for emergency landings. What the chart didn't show was that the apparent grassland was actually marsh, a thick mat of vegetation floating on 3 feet of water and mud. Koga approached the island at 80 knots. Gear up for a belly landing. The Zero touched down smoothly, decelerating normally for the first 100 feet. Then the nose dug into hidden marsh, and the aircraft flipped violently forward. The impact broke Koga's neck instantly. His body remained strapped in the inverted cockpit, suspended in the shallow water. 5 weeks later, a U.S. Navy PBY Catalina spotted the wreckage during a routine patrol. The discovery reached naval intelligence within hours. Lieutenant Commander Eddie Sanders, an aeronautical engineer assigned to naval intelligence, recognized the strategic value immediately. A nearly intact Zero. If they could recover and restore the aircraft to flight status, they could test its actual capabilities and identify exploitable weaknesses. The recovery operation began July 15, 1942. A team from Fleet Air Wing 4 landed on Akutan with tools, lifting equipment, and a barge. Petty Officer Koga's body was removed and buried with military honors. Marines and sailors spent 3 days extracting the Zero from the marsh, carefully documenting every detail. The aircraft was surprisingly light, total weight 5,400 pounds empty. An F6F Wildcat weighed 7,200 pounds empty. This weight difference explained part of the Zero's performance advantage, but it raised questions about structural integrity and protection. The salvage team noted obvious damage. The propeller was destroyed, engine mounts were cracked, Control surfaces showed impact damage, but the airframe remained structurally sound. They disassembled the tail section and wings, crated the fuselage, and barged everything to Dutch Harbor. From there, a transport ship carried the Zero to Naval Air Station North Island in San Diego. At North Island, Lieutenant Commander Sanders assembled a team of engineers and test pilots. Their mission was to restore the Zero to flight status and conduct comprehensive testing. The restoration required 8 weeks of intensive work. Engineers fabricated new engine mounts and repaired control surfaces. They salvaged a propeller from another crashed Zero found in the Aleutians. The Sake-12 radial engine, remarkably, remained operational after cleaning and inspection. As the team worked, they documented every aspect of the Zero's construction. What they discovered shocked American aviation engineers. The Zero had no armor protection, no armored seat back for the pilot, no armored glass windscreen, no self-sealing fuel tanks. The fuel tanks were fabric-covered metal, designed to minimize weight. A single .50 caliber round could puncture a tank and ignite fuel. The pilot sat completely exposed. Incendiary ammunition would turn a Zero into a fireball. Engineers calculated that armor protection equivalent to American standards would add 650 pounds. Self-sealing fuel tanks would add another 200 pounds. Together, these additions would increase weight by 16% and reduce performance proportionally. The Japanese design philosophy became clear. Sacrifice protection for performance. Accept pilot casualties to maintain aerial superiority through maneuverability and range. It was a calculated trade-off that worked when Japan had a surplus of highly trained pilots. It would become catastrophic as those irreplaceable pilots died in aircraft that offered them no protection. Commander Sanders understood they had discovered the Zero's fundamental weakness. Superior maneuverability meant nothing if the aircraft could be destroyed with a single burst. American pilots needed new tactics that exploited this vulnerability. September 20th, 1942. The restored Akutan Zero lifted off from North Island with Lieutenant Commander Eddie Sanders at the controls. The test flight would validate or disprove 3 years of combat reports. Sanders advanced the throttle smoothly. The Sake engine responded with 940 horsepower, and the Zero accelerated rapidly. Takeoff roll, 700 feet. Climb rate, 3,000 feet per minute at sea level. At 10,000 feet, Sanders put the Zero through a series of maneuvers. Maximum speed, 331 miles per hour. Roll rate, exceptional, completing a 360-degree roll in under 3 seconds. Turn performance, extraordinary. The Zero could complete a full circle in under 18 seconds at combat speed. Sanders pushed the stick forward into a dive, then pulled back hard into a climb. The Zero responded instantly, nose tracking precisely with control inputs. The aircraft felt alive, responsive in ways that American fighters were not. But Sanders also noted limitations. Above 15,000 feet, the single-stage supercharger struggled. Performance degraded noticeably. Above 20,000 feet, in high-speed dives, exceeding 350 miles per hour, control surfaces stiffened. The Zero was optimized for dogfighting between 8,000 and 15,000 feet, at speeds below 300 miles per hour. Outside that envelope, advantages diminished. The test program expanded over the following weeks. Navy and Marine pilots flew dozens of sorties, conducting mock combat against F6F Wildcats, P-38 Lightnings, and P-40 Warhawks. They tested every combat scenario: turning fights, climbing fights, diving fights, head-on passes, deflection shooting. The results were documented methodically. In turning fights below 15,000 feet, the Zero dominated completely. No American fighter could match its turn radius. Attempting to turn with a Zero was suicide. In diving attacks, American fighters held the advantage. The Wildcat could dive faster and maintain control at higher speeds. The P-38 was significantly faster in a dive. The Zero's lightweight construction became a liability in high-speed maneuvers. Head-on attacks favored American aircraft. The Zero's lack of armor meant a single burst could be fatal. American fighters could absorb damage and continue fighting. The Zero pilots had to evade or die. These findings formed the basis for new tactical doctrine. Commander John Tack, already developing innovative tactics based on combat experience, incorporated the Akutan Zero test results into comprehensive fighter doctrine. Never turn with a Zero. Use speed and altitude advantage. Attack in diving passes. Fire and extend away. Never try to climb with a Zero below 15,000 feet. Use superior diving speed to disengage. Never engage in slow-speed maneuvering combat. Maintain high speed, making repeated boom and zoom attacks. Concentrate firepower. The Zero will burn. Team tactics. Use the THAC weave, mutual support maneuvers that negated the Zero's turning advantage. The information was classified at the highest level and distributed throughout the Pacific Fleet. Fighter squadrons received detailed briefings on Zero capabilities and new tactical requirements. Pilots learned that the Zero's greatest strengths could be nullified through disciplined tactics. By early 1943, American pilots were implementing the new doctrine with increasing success. Kill ratios began shifting. The Zero remained dangerous, but it was no longer invincible. Pilots who followed the tactical guidelines survived and scored victories. Those who ignored doctrine and tried to dogfight Zeros still died. The Mitsubishi F6M represented the pinnacle of a particular design philosophy. Chief designer Jiro Horikoshi had created an aircraft optimized for carrier operations with maximum range, maneuverability, and climb rate. To achieve these characteristics with available engine power, everything else was sacrificed. The Zero's range exceeded 1,600 miles with drop tanks. No American carrier fighter came close. This range enabled operations across vast Pacific distances, but the range came at a cost. Every pound devoted to fuel was a pound not available for armor or structure. Japanese naval aviation doctrine emphasized offense over protection. Pilot training was extraordinarily rigorous. Only the most skilled aviators qualified for carrier duty. These elite pilots were expected to survive through superior skill, not protective equipment. This philosophy worked brilliantly from December 1941 through mid-1942. Japanese naval aviation achieved air superiority throughout the Pacific. Zero pilots accumulated impressive victory scores. The aircraft's reputation became mythical, but the doctrine contained a fatal flaw. It assumed a short war where initial pilot quality would prove decisive. It didn't account for attrition replacing elite pilots with less experienced aviators. It didn't anticipate enemy adaptation. The Akutan Zero allowed America to adapt. By understanding the Zero's vulnerabilities, American forces could develop tactics and later aircraft designs that neutralized Japanese advantages. The F6F Hellcat, introduced in 1943, incorporated lessons from the Akutan Zero. The Hellcat couldn't match the Zero's maneuverability, but it didn't need to. It was faster, more rugged, better armed, and could absorb tremendous battle damage. Hellcat pilots used boom and zoom tactics, perfected through Zero testing. They engaged on their terms, never allowing Zeros to dictate combat conditions. By 1944, the Zero was obsolete. Improved American fighters dominated the skies. Japanese pilots, increasingly inexperienced as veterans, died, flew aircraft that offered neither protection nor performance advantages. The philosophical compromise that made the Zero formidable in 1941 had become a death sentence by 1944. The Akutan Zero remained at Naval Air Station North Island throughout the war. Used for training and evaluation purposes, test pilots flew it regularly, using it to refine tactics and train fighter pilots heading to the Pacific. After the war, the Zero was transferred to the Smithsonian Institution. It underwent restoration in the 1970s and is currently part of the National Air and Space Museum collection. The aircraft that Petty Officer Koga flew to his death on Akutan Island had served America more effectively than any intelligence operation. It revealed the central weakness in Japanese fighter design and enabled tactical developments that shifted the air war's momentum. The story of the Akutan Zero demonstrates that technological advantage is temporary. What matters is adaptation, learning from opponents, and developing countermeasures. The Zero's dominance lasted 18 months. Once America understood its capabilities and limitations, Japanese aerial supremacy evaporated. Modern air combat doctrine still reflects lessons from the Akutan Zero. Never fight an opponent's strengths. Identify weaknesses and exploit them systematically. Use superior technology when available, but tactics matter more than specifications. The young Marine who discovered an inverted aircraft in an Aleutian marsh had found something more valuable than enemy equipment. He had found the key to victory in the Pacific Air War.